Hey there! In this video, we'll talk about generic repositories in the ABP framework. Now, before talking about generic repositories, we need to understand the repository pattern term. As a software developer, each application you'll ever create will most probably have business logic, and it'll also have some methods to deal with the database directly. We call that the data access layer. Let's suppose we're using SQL Server on Entity Framework Core. We'd have the find async method, or the first or default async method, or even the where method. And these are all methods to deal directly with the database. When we're building good software, we'll put these methods inside of if statements to make sure that the data that's going to the database is valid. We can't have the user, for example, order a product that's out of stock. That's business logic right there. And so let's say in the far future you wanted to switch from SQL Server to PostgreSQL, for example. It would be extremely difficult to do that if those methods that deal directly with the database were merged with our business logic code. They need to be separated. And that's how the repository pattern works. The main reason of using the repository pattern is to keep the data access layer separate from the business logic. So what do we exactly do? We'll simply create an interface and we're going to put all the methods that deal with the database inside of it. We'll then create a repository class that will implement this interface and then customize all the methods that deal with the database. And then when we need these methods, we'll inject the interface, whether it's in the controller or anywhere else. We'll use the interface to call those methods, and then we will wrap them with our business logic. And this will make our data access layer separate from our business logic. We kind of performed these steps in every to-do web application video. We would first create an interface in the application contracts layer. Then we'd put all the methods that deal with the database in that interface. Those methods would return DDOs, so we had to create a DDO class inside of the application contracts project. And finally, we would create the application service class that implemented that interface and injected the iRepository that we later used its methods that dealt directly with the database. The getList async, insert async, and the delete async. These were all coming from the iRepository that we've injected. The iRepository, the generic repository that comes from ABP itself. And congratulations, this is our lesson today. Repositories in practice are used to perform database operations for domain objects. Generally, a separate repository is used for each aggregate root or entity. And we've got 4 types of generic repositories that we need to take a look at. First off, we've got the iRepository of the type entity, and it's got these 3 methods, the delete async, find async, and get async. And it inherits from 2 generic repositories, the iBasic repository of the type entity and the iReadOnly repository of the type entity. The iBasic repositories got these methods, the delete, insert, and update async, and the delete many, insert many, and update many async, which are methods that perform bulk operations in the database. The iReadOnly repository of the T entities got these methods, the getList async, getQueryable async, with details, and with details async. It's also got a property, which is the async executor, since we cannot always use all the async extension methods when we're using the application startup template. We've got a few solutions to work around this issue, and one of them is by using this async executor. And you can read more about it in the document. It's not our main course. In both the iBasic repository of the T entity and the iReadOnly repository of the T entity inherit from the iReadOnly basic repository of the T entity, which has got these 3 methods, the getCountAsync, the getList async, and the getPageList async. And it inherits from the iRepository, which is an empty interface, only to mark these classes as a repository. Now, if we look closely, the iRepository is the main repository that we usually use. It inherits from most of the other repositories, and it also supports the iQueryable, and it's all good, right? But let's suppose that we are creating a reusable module, and the database provider does not support the iQueryable. In that case, we prefer to use the iBasic repository since it doesn't expose the iQueryable interface outside of the repository. And this kind of better isolates the underlying database provider, which will make you free to implement your repository even with a provider that doesn't support the iQueryable. So we prefer to use the iBasic repository only in our reusable modules, so we can avoid coupling our business logic on the iQueryable features and keep querying inside the repositories. However, this is just a case of its own. In practice, both our DB providers EFCore and MongoDB already support the iQueryable. And so you can just use the iRepository and it'll be all fine. Or you can use the iBasic repository. You get to choose the level of the isolation. Now let's have a little example from the documentation that shows the usage of a default generic repository. We've got our app service class, which is the person app service. It inherits from the application service as usual. It injected the iRepository of person and good, and it's got two methods, the create async method and the get count async method. The create method passes a DDO as an input. It puts this input as the name of the new person object that it's created, and then it inserts this person to the database using the insert async method that comes from the iRepository. And in the get count async method, it passes in the filter and gets a filtered count of all the people in the database, using the count async method that comes from the iRepository. We've got a list of all the standard repository methods. Each are self-explanatory, I'm guessing. However, we've got two overloads of these methods. The update async and delete async methods update or delete an entity by entity object or its ID, and also the delete async method can delete multiple entities by a filter. We can also take a look at another example with the link over the repositories. Repositories provide the getQueryable async method that returns an iQueryable of type entity object. And you can use this object to perform link queries on the entities in the database. You can see right here we've injected the iRepository the same way we've done it before. And then we'll use the iQueryable of the person entity, and we'll call the getQueryable async method from the iRepository and put the value in the queryable. And then we can create a query, and we can execute it to get the list of people. And we can also convert it to DDO and return it to the client. And we can also use the link extension methods. And as for the best practices part, do not forget to add an optional cancellation token parameter to every method of the repository. And add an optional boolean include details equals true as a parameter for every repository method which returns a single entity. And keep it false for every repository method which returns a list of entities, of course. Alright, let's see the generic repositories in action. We'll first go to the Entity Framework core project in the source folder, and we're going to find the Issue Management DB Context Model Creating Extensions class, and we're setting up the mapping of EFCore right here, putting in the customers and the contact information, setting the name and the max name length. We're getting this from the class from the previous video. And same thing for the surname, and we're putting it as required and everything. And we're also setting up the relationship between the customer and the address, which is the value object. A customer owns one address. This owns one means that the address cannot exist without the customer. And also it has many relationship with the contact information, the phone, the email, and such. So one to many. And the foreign key, which is the customer ID. And we're also doing the same thing with the contact information. The foreign key right here is the primary key right here along with the name. And we're setting the name and the value along with some validation. And we'll also add our dbsets right here. So first thing, the interface right here. We've added the customer's dbset. And right here is the class. Here is the customer's dbset right here as well. We have also got our tests right here. We've got the domain tests where we are going to run our tests on the generic repositories, but first we need to show you the data seeder that will run every time we run our unit tests. So right here in the dataseed contributor class, we've injected the iGUI generator in the iRepository right here, and we've also created a simple method, and this method will seed the data every time a unit test runs. it'll create a new instance of the customer aggregate root. It'll create an ID right here, and this is the first name and this is the last name. And then it'll pass it into the variable right here, and then it'll use the iRepository that we've injected right here to call its method, the insertAsync method, to insert the variable into the database. And the createCustomers method will be called right here when we seed the data. And in order to use these repositories, we need to register them. So we'll go to the Entity Framework Core test project, and we're going to find the test module class. And we're going to find the configure services method right here. And we will use the add ABP dbcontext method right here, so we can add the default repositories. This method, as you can see right here, it registers the default repositories for all the entities in this dbcontext. We've also got the Boolean parameter include all entities, and it's set to false. By default, it registers the repositories only for aggregate root entities. If you wanted to register all the entities, you need to set this to true. But as for now, all of our tests are going to be on the aggregate root, so I'm going to keep it at false. Now make sure that you've added this snippet and we can get testing. I'm going to close all the tabs and let's get back to here. And we'll find the domain tests is right here. So we've injected both the iRepository and the iGUID generator, and we are going to test the methods that come from the iRepository that deal directly with the database. So for the first test, we've got a should list customers. It's just going to get the list of the customers, right? And according to our dataseed contributor, it's not going to be null because we've already got 3 customers. I've forgotten to mention something, to be honest. If we go back to the source folder and to the domain project, we've got the nullable property that came with .NET 6 and it completely slipped my mind. So it is in the domain project and that includes our value object, the address. And since we are seeding the aggregate root, the customer aggregate root, that includes the value object, this will throw in an error. It'll say that the address cannot be null, blah, 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 something like that. So as a temporary workaround right here, I made all of these nullable just for this case, just for this example, only for that. And then I added the migration in the HTTP API host project and updated the database, of course. Okay, so for the first one, we are using the iRepository to call its method, the getListAsync. And as we said, the data has been seeded and it will not be null. So it should not be null. That's for the first one. For the second one, we're calling the getPageListAsync method. If we take a look right here, onto the first 3 parameters that it's got, we've got the skip count. The first one's the skip count. The second one is the max result count, and the third one is sorting. So let's take a look again. The first one is 0, so there is no skip count. The max, however, is 2. So we're putting a cap, as if we take a look right here, we see we've got 3, right? And right here, we have got the maximum 2. And it's going to get the count of the name of the customer instances that we have seeded. As you see right here, it should not be null first. Of course, it's not going to be null because we've got it passed right here. It's not going to be null. And second, the count should be 2 because we have already told it that, hey, we have the max result count is 2. If we get 3, you put 2. If we get 10, you put 2. And it should pass as well. The next unit test is the should count customers. We're using the unit of work async here, and we're calling the count async method from the repository. And according to the seeded data, it should be 3. The next one, we are testing the get async method. As you can see, we are giving it an empty ID right here, and it should throw an exception, an entity not found exception, because the ID is empty. All right, that's for the get async. And if we give it all of the IDs that are not empty, this is the not empty, it'll return multiple records. So right here, it's returning no record, it's empty, and right here, it is returning multiple ones at the same time. So it will throw an invalid operation exception. And if we take the first or default one by the ID, and with the unit of work, we pass it in the customer ID, and then get this customer ID with the get async method, it should not be null. It'll be the first one that we've got in the dataseed contributor. So this was the get async. Let's take a look at the next one, which is the find async. As you can see the difference between these two. If you give an empty ID to the get async, it will throw an exception. But for the find async, it will return null. But if we return multiple records, it'll throw the same invalid operation exception. And the same thing right here if we put the first or default by ID from the repository as well, and then we pass it to the customer ID, and then we use the find async method that's coming from the repository to get the customer ID, it should not be null. Next one is just inserting a new instance. We're creating an ID right here and giving it the first name and the last name. We'll then use the repository to call its method, the insert async method, so we can insert the variable to the database. And then we'll create a new variable right here, and we are going to use the repository to call its method, the getAsync method, to get the customer by its ID. We'll pass that to the new variable, and its name should be Jake, just like here. We're doing the same thing right here, but we are using our method that we've created in the last video, the setName method, so we can change the name of the customer variable right here. And we're also using our generic repository to call its method, the updateAsync. And after that, we are using the generic repository to call the getAsync method so we can get the customer by its ID and pass it to the new variable, which its new first name should be Josh. And we'll see if it passes. And right here we are calling the count async method from the generic repository, and it should be 3, right? We have seeded 3 instances right here, so it should be 3, right? After that, we are going to use the delete async method from the generic repository where the ID is not empty, so it's going to delete all of them. After that, we are going to use the count async again and check if the count is 0, and it should be 0. And last but not least, the last test. We've created a list instance right here, and inside of it, we've created 2 customer instances. Same thing, first name and last name, and just a good. And after that, we've called the insert mini async method, which is a bulk operation to insert the list of the customers. After that, we'll keep the connection going with the unit of work so we can check the count of the customers. We'll call the count async method and check if the number is 5 because 2 right here and 3 already seeded, and it should pass. Let's take a look now. And they have all passed. Please make sure to read the documentation and the best practices, as this is just a way to show you around the framework. This was the generic repositories of the ABP framework. Thank you for watching and see you next time.